Welcome to Spaceverse, your portal to cosmic adventures. A rocky traveler from the depths of interstellar space has just given astronomers something extraordinary, a glimpse into alien chemistry. This isn't just another comet drifting through our solar system. This one, known as 3I Atlas, is a visitor from another star, and it's leaking water into space at a rate so powerful that scientists compared it to a fire hose running at full blast. Using NASA's Neil Gehrels Swift Observatory, researchers have done something never accomplished before. They've detected the chemical fingerprint of water spilling from an interstellar comet. This makes the 3I Atlas only the third known object from another star system ever observed as it passes through our cosmic neighborhood. And with this discovery comes an astonishing revelation. The ingredients for life's chemistry are not unique to our own solar system. When scientists study comets, water serves as the universal yardstick. It's the standard for measuring how sunlight drives a comet's behavior, dictating how it sheds gas and dust into space. So, detecting water in an interstellar visitor isn't just exciting, it's revolutionary. It allows astronomers to compare 3I Atlas directly with comets that were born right here in our solar system, revealing how similar or different the building blocks of distant planetary systems might be. Dennis Bodwitz, a professor of physics at Auburn University and co-author of the study, beautifully summed up this discovery. When we detect water, or even its faint ultraviolet echo, OH, from an interstellar comet, we are reading a note from another planetary system. It tells us that the ingredients for life's chemistry are not unique to our own. Imagine that, a message from across the galaxy written not in words, but in the faint ultraviolet glow of broken water molecules. A discovery beyond expectation. Using the Swift telescope, Bodwitz and his team observed 3I Atlas during July and August 2025, when the comet was roughly 2.9 times farther from the Sun than Earth, far beyond the distance where water ice typically vaporizes. At that range, the sunlight is too weak to directly heat a comet's surface enough for ice to turn into gas. So when Swift detected the faint ultraviolet signature of hydroxyl, a molecule produced when sunlight splits apart water, the researchers were stunned. They had found water vapor where it shouldn't exist. To isolate this delicate signal, astronomers had to get creative. They stacked dozens of short, 3-minute exposures, combining over 2 hours of ultraviolet observations and 40 minutes of visible light. This careful process allowed them to reveal the comet's subtle ultraviolet glow, a cosmic fingerprint that confirmed what they suspected. 3I Atlas was gushing water into space. The results, published on September 30th in the Astrophysical Journal Letters, showed that 3I Atlas was losing water at about 40 kilograms per second, roughly equivalent to the water output of a fire hose running at full blast. To put that into perspective, that's nearly 3,500 liters per minute, pouring out into the void of space. A hyperactive alien comet. Based on that rate of water loss, the team estimated that at least 8% of the comet's surface must be actively venting. For comparison, most comets native to our solar system have only 3% to 5% of their surface active at any given time. So why is 3I Atlas so hyperactive? The answer may not lie in the comet's solid surface at all. Instead, it could be surrounded by a cloud of icy debris, small fragments that were once part of the comet but have since drifted free. Observations from Gemini South and NASA's Infrared Telescope facility showed hints of these icy clumps floating in the comet's coma, the cloud of gas and dust enveloping its core. When sunlight hits these icy fragments, they warm up and begin to sublimate, turning solid ice directly into vapor, just like tiny steam vents in space. This process could explain how the comet is releasing so much water even though its surface itself remains far too cold for direct sublimation. It's a fascinating scenario. An interstellar traveler surrounded by a halo of icy rubble, each piece carrying water from a long-lost star system, now slowly evaporating under our sun's distant light. Every interstellar comet is a surprise. Zexi Crossing, the study's lead author and a postdoctoral researcher at Auburn University, emphasized just how unique each interstellar visitor has been. Oumuamua was dry, Borisov was rich in carbon monoxide, and now Atlas is giving up water at a distance where we didn't expect it. Each one is rewriting what we thought we knew about how planets and comets form around stars. Let's pause on that thought. When Oumuamua, the first known interstellar object, zipped through our solar system in 2017, it didn't behave like any comet we'd seen. It showed no sign of gas or dust, suggesting a dry, rocky structure. Then came 2I Borisov, a much more traditional comet rich in volatile materials like carbon monoxide, resembling comets we know but still foreign in its origins. Now, with 3I Atlas, the story gets even more complex. Here's a comet leaking water, but doing so at a distance where water shouldn't even be vaporizing. This means that the diversity of materials in interstellar objects is greater than we imagined, and that every planetary system might have its own recipe for making comets and planets. In a way, each interstellar comet is like a sample courier carrying the raw ingredients of another world into our solar system, allowing us to study from afar the chemistry of alien stars. The next phase, a cosmic handoff. Although 3I Atlas has faded from Swift's view, the story isn't over. The comet was spotted again in early October by the European Space Agency's Mars orbiters, as it passed about 30 million kilometers from Mars. And ESA has even bigger plans. In November, they intend to turn the Jupiter Icy Moons Explorer spacecraft toward 3I Atlas. That's right, a spacecraft designed to explore Jupiter's frozen moons is about to turn its instruments toward a comet from another star system. JUICE will observe 3I Atlas just after its closest approach to the Sun, when it's expected to be at its most active. This will be a golden opportunity to watch the comet's icy jets in full force, to see how it behaves under solar heating, and perhaps learn even more about its composition. The European Space Agency noted that JUICE is currently positioned on the far side of the Sun, meaning data transmission is slow and limited to a backup antenna. Because of that, scientists won't receive JUICE's comet observations until February 2026. But when the data finally arrives, it could offer our clearest and most detailed look yet at an interstellar comet in full bloom, a message from beyond the stars. Think about what this means for our understanding of the universe. For decades, astronomers have wondered whether the materials that gave rise to life on Earth, water, carbon compounds, organic molecules, might also exist elsewhere. Now, with every new interstellar visitor, we get a little closer to answering that question. Oumuamua told us that alien objects can drift into our solar system. Borisov showed us that some carry rich, volatile chemistry. And 3I Atlas has now proven that even water, the essence of life, exists and behaves in remarkable ways far from home. Each of these visitors has rewritten the rules of cosmic chemistry, expanding our view of what's possible in other solar systems. 3I Atlas reminds us that the building blocks of life are not confined to Earth, or even to our Sun's family of planets. They're spread across the galaxy, carried by icy wanderers born under other suns. As Bodewitz so perfectly put it, it tells us that the ingredients for life's chemistry are not unique to our own. Those words carry profound weight. They hint at a universe where the seeds of life, water, carbon, and simple molecules may be scattered among the stars, waiting for the right conditions to bloom again. Perhaps, somewhere out there, around a distant sun, another world is being watered by the same cosmic ingredients now streaming from 3I Atlas. So the next time we look up at the night sky and see a faint streak of light, we might be witnessing more than just a passing comet. We could be seeing a message from another star system, a frozen time capsule that's traveled for millions of years, carrying secrets from worlds we may never see, but can still learn from. 3I Atlas is just one traveler among countless others yet to be discovered. And as our telescopes grow sharper and our spacecraft more ambitious, the story of these interstellar visitors is only just beginning. The universe has a way of humbling us, showing that what we thought was rare may actually be universal. From interstellar comets leaking water to galaxies billions of light years away, every discovery reminds us that we're part of something vast, ancient, and interconnected. If you enjoyed exploring the cosmic story of 3I Atlas and what it tells us about life's ingredients beyond Earth, make sure to like, subscribe, and keep following Spaceverse, where we journey through the mysteries of the cosmos, one discovery at a time. Until next time, keep looking up, because somewhere out there, another traveler might already be on its way.